In this video lesson, we're going to complete two more mole conversion type problems. The question on the screen asks, what is the mass of one single bromine molecule which has the formula Br2 since it's diatomic? The tricky thing about this one is most students read it as what is the mass of one mole of bromine, and therefore they will just find the molar mass assuming that that's the answer. But the problem is literally asking, what is the mass of one single bromine molecule? Now, one molecule of anything is going to be extremely small, so our mass that we're going to get is going to be very small as well. Therefore, we're going to have to think about this in a different way. Think back to our helpful guide that talked about where mole can be converted from molecules and grams and back and forth. Think about what the problem is asking and what the problem is giving us as information. The problem is asking what is the mass of a molecule. So we're going to be converting to grams. Now, what are we starting in? Like I said, most students think that it's the mole, but it's not. We're actually starting in molecules, which is a particle. And so we need to go from particles, which in this case is the molecule, convert that to moles, and then once we're in moles, we can then convert to grams. So that's going to be our step. So what do we start out with? Well, we start out with one molecule of bromine. So one molecule of Br2 is what we're given. So the first thing we need to do is we need to convert it from molecules to moles. If you remember back to the helpful guide, this is where we're going to use Avogadro's number. So we set up our conversion. Molecules goes on the bottom, moles goes on top, and for every 1 mole of any particle or anything that we're looking at, it will equal Avogadro's number, which is 6.022 times 10 to the 23rd. This will cancel out our molecules, and therefore we are now in moles. Once we're in moles, we can then go from moles to grams using the molar mass of whatever it is we're looking at. In this example, we're looking at bromine 2, or Br2. So 1 mole of Br2 has a mass of 159.8 grams. The moles will cancel out, and now we will be left in grams, which is what we want. So now all we have to do is just multiply through. So our answer is 2.654 times 10 to the negative 22nd grams. First of all, notice that's a very tiny number, which is what we expect since we're only finding the mass in grams of one individual molecule. But secondly, I want you to note that in the problem, there were no numbers. And so therefore, my significant figures is going to be based off of the conversion factors that I used, since 1 in this case is actually an exact number 1. All right, let's look at one more problem. If you have 5 grams of sodium dichromate, which has the formula Na2Cr2O7, how many oxygen atoms does that contain? First of all, note that my program that I'm using doesn't allow me to do subscripts, but those numbers 2, 2, and 7 would be subscripted. All right, just like the last problem, we need to look at what we're given and what we're trying to figure out so we can develop a roadmap to get us to where we want to go. We're given the fact that we have 5 grams, and so grams is going to be what we start out with. Now we're asked to figure out how many oxygen atoms are in that particular mass of sodium dichromate. So how many atoms would be how many particles that we're going to? So we know that by now that you can't go from grams to particles directly. We first have to go from grams to moles. And then once we're in moles, we can go to particles. Now, what are we looking at in this problem? Are we looking at a single individual element, or are we looking at a compound? It may be asking us to find out how many oxygen atoms, but we're actually looking at a compound here. And so when we go from moles to particles, the particle in question we're actually going to is a molecule, since we're looking at an actual compound. Once we're in molecules, we'll actually have to go one more step, and that step will be to atoms. This step will be explained when we start to work out the numbers. So let's go ahead and get started. I'm going to start out with my 5 grams of sodium dichromate. So 5 grams of Na2Cr2O7. That looks a little better now that I can actually subscript the numbers. All right, my first step is I want to convert from grams to moles. So I'm going to set up my conversion, grams on the bottom, moles on the top, and this is where I'm going to enter my molar mass. The molar mass of the mass of 1 mole of sodium dichromate is approximately 261.98. Now normally we do molar mass to 4 significant figures, but I figure just to be even that much more accurate, I'll put all 5. So once I have it set up like this will cancel out the grams, and now I'm in moles. Now, when I go to set up my next conversion, this is where I'm going to move to particles. Okay, for every 1 mole of Na2Cr2O7, I will have 6.022 times 10 to the 23rd. And since I'm in a mole of a compound, the particle that I'm looking at is going to be molecules. I can't go directly to oxygen atoms at this point because I'm still in the actual molecule of Na2Cr2O7. So this step cancels out the moles, and now I'm in molecules of Na2Cr2O7. Now let me minimize the screen just a little bit so we can add on and do our final conversion. Now that I'm in molecules of the compound, I can now look at the individual atoms. So this is what it's going to look like. For every 1 molecule of Na2Cr2O7, this is where I'm going to make my switch to atoms. 1 molecule of sodium dichromate will contain 7 atoms of oxygen. I get that number 7 from the subscript 7 right there. This is where I'm going to make the switch, and I can now go cross out my molecules, and I'll be left in atoms. I want to make sure that that's really clear what I just did. So I'm going to, right below, just do a really simple example so hopefully we can kind of understand. Recall that the mole is a unit of quantity, much like the dozen. So let's say I tell you this. Let's say I have 10 dozen couples. And I want to know how many individual people there are. Well, you can't go directly from dozen to people because the unit we're looking at is couples. So I would first have to say, okay, 1 dozen of anything is 12, but what is it 12 of? Since it's a dozen couples, I have to say it's 1 dozen is equal to 12 couples. And then once I do that, I can now say 1 couple is equal to 2 people. And this is where I will actually get my number of people. It's the same idea or same line of thinking that we did up above. So now that we've got that all set up, let's actually go through and calculate what my answer would be. Let me get rid of some of this writing here. There we go. All right, so looking up at the top, I'm going to go ahead and calculate through and get my answer. My correct answer in 3 significant figures would be 8.05 times 10 to the 22nd atoms of oxygen. And just once again to show, I'm getting my 3 significant figures from the 5.00. Molar mass, Avogadro's number, and 7 are all exact numbers or have been rounded for ease.